Final Project for AP Calculus AB by Leslie Oy. Topic 1. Optimization. Optimization is the process of finding an absolute maximum or minimum value of a function when given a set of constraints. When we perform optimization, we need to know how to do the first derivative test. This uses critical values of a function to determine whether a local minima or maxima value exists. There are some steps we should follow when doing optimization. First, we need to determine what we are trying to optimize. Then, write the equation to be optimized, and then perform the first derivative test for relative extrema. After that, we will compare our local extrema to endpoints of the domain, and then finally conclude and include units in our answer. A real-world application of optimization can be understood through how businesses respond to the economy locally and globally. Oftentimes, companies will attempt to find ways of how to maximize their profit, but also minimizing the cost it takes to create their product or deliver their service through this process of optimization. A career that uses optimization is farmers. Farmers are an example of many careers that utilize optimization. Farmers use optimization to maximize the amount of food and profits that it will make. For instance, in crop planning, farmers are given an idea of the forecasted crop prices and weather growing conditions, so they need to determine through optimization how much of each crop to plant for maximum profit. Another way farmers use optimization is through feed blending. The farmers already know the amount and price of the available feeds required for their animals, so they need to discover the optimum blend of feed ingredients that can also minimize the total cost it takes to feed their animals. Topic 2. Velocity, speed, and acceleration. Velocity tells us how fast an object is moving, but also its direction. So a positive velocity goes up or right, while a negative velocity goes down or left. Speed, on the other hand, is the absolute value of velocity. It tells us the rate of motion regardless of the direction. This explains why speed is never negative, and acceleration is the rate an object's velocity is changing. Velocity is essentially the derivative of the position function. Speed is the absolute value of the velocity function, and acceleration is the second derivative of the position function or the derivative of the velocity function. A real-world application of speed, velocity, and acceleration is cars. Particularly, we can look at race cars to connect to speed, velocity, and acceleration. Speed is the measure of distance traveled over a certain amount of time. So, race cars in the Daytona 500 travel a distance of 500 miles in approximately 3.1 hours. So, speed is distance over time, so this would be 161 miles per hour. So, what about velocity? Velocity is actually displacement over time. Displacement is a measurement of how far from the starting point an object ends up in. So since race cars in the Daytona 500 end at the same point they started, the velocity is 0. Acceleration by the common population is known as speeding up, but in reality it should be called velocitying up. We could look at a constant rate of acceleration, but in the real world this is not as common. Acceleration in race cars, for example, could go from 0 to 40 for the first 2 seconds, but then go from 40 to 60 in the next 2 seconds. Acceleration would be twice as much the first 2 seconds in comparison to the last 2 seconds. A career that utilizes speed, velocity, and acceleration in their job is an amusement park designer. When constructing an amusement ride, designers must be able to find a balance between fun and safety. They do this based on their knowledge of speed, velocity, and acceleration. Amusement park designers want to make a ride allowing the rider to feel a thrill of speed. This is mainly achieved through speed control. Designers, along with the help of engineers, will carefully implement the placement of hills, curves, dips, straightaways, braking systems, and loops. In addition to speed, velocity is also accounted for, especially when planning a roller coaster. A roller coaster is named because of how it coasts through the entire track. The majority of coasters do not require any outside forces, aside from braking systems. Oftentimes, designers trade height for velocity and velocity for height, and a majority of the calculations made require measurements of velocity. Have you ever felt a ride where you felt weightless? This sensation is made by accelerating down around 22 miles per hour every second in the air, which is basically falling down at a rate equal to the pull of gravity. Amusement park designers can also calculate acceleration at different parts of their ride. For instance, downhill or on a sharp curve, the ride will likely increase in velocity and accelerate. Uphill or in a straight line, the ride will likely decrease in velocity and decelerate. Designers are aware that gravity can act as a force for acceleration, so mass and the force, such as push and pull, are influencing factors that contribute to acceleration. Thanks for watching. I hope this video helped.